Anyway, we're glad to be here, and I'm going to go through a presentation that I call Groundhog Day. And you might be wondering why it's called Groundhog Day. Well, it's because I keep seeing the same things. And so what I'm going to try to do is just bring some experience that I've had personally from installing these materials and inspecting these materials, along with kind of working with the association for the past kind of 21 years and seeing just kind of how things happen. So we've done about 6,000 site audits or inspections, whatever term you like. And so this is a little bit of an extract of information from those going, what are the same things that we keep seeing? Okay, so the intent is going to be very visual. We're going to take a look at some kind of generic things that are going to apply by all the materials, and then we'll get into the specifics, right? There's some things, if you're looking at a specific air barrier, some things to think about, right? And I really want to show what is happening, why it's happening, and how to fix it, right? So I'm hoping to not have a whole bunch of horror pictures. It's going to be like, hey, we found this, here's why it's probably happening, and kind of how do we fix it. So this is an AI continuing education presentation in case anyone is looking for that. So we can always provide certificates or registration, all that sort of stuff. So the focus of this course really is like being on the site and what to look for, mostly from a visual standpoint. Okay, so there is some kind of testing you can do, and I'll go through some of that testing now. In the slides I'm going to provide after the presentation, there's going to be an end part that gets into kind of adhesion testing. Now, I'm not going to have time in an hour to go through it, but at least you're going to have it as a reference. Okay, so it's going to be right at the end of the presentation. I'll quickly just whip through it to what it means and how you can use it if you're going to do some adhesion testing, which is really a good way to test if the substrate was prepared well and also if it was installed well. With some of these materials that need to stick, like a fluid or a spray foam that's self-adhered, how well it sticks is a very good indication of how well it was actually installed. Okay, so here's a bit of a overview of learning objectives. We're going to talk about site quality assurance. We're going to talk about some of the typical issues that we find. And there may be some from personal experience that you found that maybe you've looked at and you're like, I don't know why that's going on. So hopefully if there's a picture such as that, I'll be able to dig into it a little bit more. And so we're going to deal with some general and then get into very specifics by material type. Now, there's a big difference, and I'm not going to spend a whole lot of time about this, but from the association standpoint, we've implemented kind of a quality assurance program. And the reason we've done that is because we can't necessarily rely just on, an inspector showing up a couple times during the project and hoping that we're going to catch everything. It's just, it doesn't work and maybe isn't the most effective. So kind of the approach that the association takes is like, okay, like what are all the things that we could do to make sure that we have a good air barrier, we have a good airtight building, reduce our moisture risk, all that sort of stuff. So we had implemented what we call quality assurance, right? And so it is a little bit different between kind of quality assurance and quality control. So think of quality assurance of kind of like big picture. We're going to do these 10 things, where when we think about quality control, this is really where we're doing kind of the audits, inspections, site observations. And that's kind of what this presentation focuses on, is this one piece out of the pie. Well, what we've kind of thought about is, we've applied this kind of like the car manufacturing industry. And we said, well, if we're going to really impact the industry to make sure things are done right, we could look to car manufacturing as maybe an industry that we can steal some ideas from. And so we've implemented the QAP program because that kind of helps us really look in and go like, why are the problems happening, right? What can we do to prevent them? What are some of the things that we can put into place so that when we go to a job site, that it's done well, right? And we're maybe just catching, the bits and pieces that maybe weren't done well. And so if you think of a car manufacturing production line, back in the 60s or 70s, you kind of have like this inspector at the end of the line, and he goes, well, that car has a defect, and well, that one's okay. And, that car has a defect. And so you have this pile of defect cars and a pile of cars that are like, okay. And then someone said, well, rather than just trying to find the errors, why don't we find out what's actually going on? Let's fix it in the design or installation or whatever it happens to be, that this inspector at the end of the line is like, good car, good car, good car, good car, and maybe like a bad car, but it's not too bad, and it's few and far between. Okay, so the way that we've kind of accomplished that is going, well, we really need good trades and good materials, and we need to, have field audits, and we need to have some form of constant improvement. So we've kind of come up with this list of things that we feel is like, if we really want to impact quality, this is kind of the way to handle it. So this is just a quick overview of, what we're going to cover today, which is really just one circle out of this big circle of things that goes into making sure that we have a good job. But this inspector becomes that second set of eyes. We know nothing's going to be perfect. It means if we've trained people to do it well, I don't know, it's Friday, it's long weekend coming up, we're going to rush through some things, we're all human. So that's where that second set of eyes, or that site quality control, can really help us. So when we're going out to a job site, what are the key things that we actually need to audit? And it's going to be fairly consistent from system to system. Okay, so we want to take a look at the materials being used, and we'll talk a little bit about that. The qualifications, we need to look at environmental conditions. We'll talk about that. Substrate conditions and prep, that's a big one. So we're going to spend some time on that. We'll be able to do some visual inspection, and there's some common things from material to material, but some things that are very specific for a material compared to another material. So if we can understand what to look for, then we can address and kind of flag these things on a punch list or a inspection report that says, hey, this needs to be fixed. Then we'll get into some physical testing, right? So it's like, we'll have the visual aspect, but then we'll also have some physical testing. So is that, thickness of the materials? Is it, how well does it stick? Whatever kind of inspection plan we come up with, we're going to do some physical testing that's going to say, hey, this is good. It meets a performance standard. It doesn't, whatever that happens to be. And then as part of that, we're going to look at documentation. We'll touch on safety, and we'll look at, really the important part is like, what do we do to fix it? And do the people on site, the general contractors, subtrade, whoever it is, really understand what needs to be done to fix? So it could be fixed, we can come out and ensure that it has been fixed correctly. Okay, so this is kind of like, if I'm going out to the job site, this is kind of my checklist of, here's all the things that I want to look at. So we'll go through each of those different types of things. So let's start off with just some of the generic things that are going to apply to really every material. Okay, so we're going to look at some general environmental conditions. We're going to look at substrate prep, and those two things are going to be fairly consistent from product to product. There's not going to be this huge wide variation, right? Where one can be installed in plus 70 and the other can be installed in minus 50. It's like they're all got this kind of band that they can be installed with. And the same kind of happens when it comes to substrate prep. Substrate prep for one material generally going to be the same for other materials that rely on adhesion. And then you'll have some materials that are mechanically fastened. And again, the principles of how we attach them mechanically tend to be the same. So I call those kind of the general things. And then we're going to take a look at kind of 6 different types of air barrier systems. So self-adhered, fluid applied, sprayed foams, and there's a couple different types, and I'm going to talk about those different types. We're going to talk about insulating and non-insulating board stock and what actually that means. So in essence, it's like we're using an insulation board, taping seams, or we're using something like exterior gypsum, plywood, whatever it happens to be, and we're taping the joints and seams. And then the last being commercial building wrap. So that's kind of like the house wraps that you might see on a house, single family, multifamily, or large commercial buildings too. So we're going to dig into these. Now there could be more air barrier materials out there, but these are kind of the ones that would be considered the more popular ones when you're dealing with commercial and institutional construction. When you're getting down to more of the residential side of things, that's typically where you're going to find more of the house wraps. We're seeing some fluids becoming a little bit more popular. We're seeing some self-adhered becoming a little bit more popular, but really the kind of house wrap, building wrap tends to be the biggest market share when it comes to single family and residential type homes. Okay, so let's get into kind of like some of the general environmental conditions. And we're going to talk about ambient, substrate, and relative humidity and what those impacts are. So from an ambient temperature side of things, all materials are going to have some parameters for storage, right? And it's going to depend really what is the makeup of the material. So for instance, if we take a fluid applied membrane, it's going to come in a bucket. Depending on what's in it, so say it's a water-based system or maybe it's solvent-based system, those systems are going to have some limitations in regards to how cold they can be. And typically, if you have a solvent-based system, it's able to go to a little bit lower than, say, what you could do with a water-based system. So sometimes a contractor may have to switch materials even throughout the project, say in the spring and fall where maybe it's hot and cold and at night it gets cold, but it's warmer during the day. And you have those fluctuations, okay? So all these materials are gonna have some like high end and low end. Now, as we go around the building, we're gonna even find that it's gonna be different temperature conditions around the building. So you might have sunny side on one, shaded on the other. Well, you can have a fairly significant ambient temperature difference and substrate temperature difference depending on where the sun is, right? So there could be times actually where you show up on a job site and it's on the shaded side and maybe it's like, hey, we can't install material because we're below what those limitations are. But you know what? We can go around the building and it's okay to install here. So understanding what the substrate and the limitations that the manufacturer has is important. All this is going to be on their technical data sheet, their installation instructions. So it isn't too hard to kind of figure out what those highs and what those lows are, okay? Now, one thing to keep in mind is you can have a very big difference between substrate and ambient, okay? So here's an example where it's about 61 degrees Fahrenheit. So, not too hot, not too cold, kind of right in the middle. Well, we have this temperature gun and we're putting it on the surface and we're seeing that the substrate temperature of that material is 219 degrees. So this is a perfect example of how big of a difference it can be, that even though it's 61 out and you're like, hey, this looks good, the installer might not be able to actually install because of how hot that substrate is, okay? So we're always got kind of two things we're keeping in mind, kind of what the temperature out is, but more importantly, even what the substrate temperature is, right? So some of these materials, if they go on a hot substrate, such as 219 degrees, can start melting, right? So if a fluid, it could start melting. If it's a self-adhered, it can actually start to make the rubberized asphalt on the back kind of soft and droop down. If you're using a spray foam, well, the spray foam can have a bit of a weird reaction if it's sprayed on something too hot. So we're always thinking substrate and ambient both together, and they can both have significant impact on how things go. Now, from a relative humidity standpoint, that tends to be basically kind of like temperature, right? So there's going to be some relative humidity conditions for some of these materials, and it's really going to impact how quickly things cure. So again, if we're using something that's more of a water-based, it's going to take longer for these materials to cure. If it's more of a chemical cure or a solvent-based materials, then it's not necessarily impacted by relative humidity as much. But higher relative humidity, if it's like really high, these things can take quite a bit of time to actually cure up, right? With some of these, specifically things that are sprayed on like a spray foam or a fluid applied. So you do have to be careful, and even the relative humidity can impact even how these things cure. Okay, so if you think of something like a spray foam, typically they'll have a condition of, don't spray 90% and above relative humidity. And because they say that, what can happen is you can actually change that chemical reaction. So you might be, hey, Ryan, it's nice out. Hey, it's sunny. I'm going to just spray this, but it's like super, super humid. The foam just isn't going to set up as properly. Okay. So relative humidity tends to impact cure and tends to impact some of the chemical components within, say, something like spray foam, that you do need to be concerned about some of these general environmental conditions when it comes to relative humidity. So if we add those three things up, we need to be concerned about ambient temperature, substrate temperature, and relative humidity. And all those things will have a play in regards to, can we install this air barrier at this specific day and this specific time? Okay, so just keeping in mind, once we hit those shoulder seasons of fall and spring, where we have big temperature fluctuations, we need to maybe pay a little bit more attention to that. So the next common thing that we have for all these things is substrate. And I would say this is maybe one of the main culprits that we see that impacts poor application. And there's a couple reasons for that. One, the trade that does the substrate is typically not the air barrier subtrade, right? So they're relying on the mason or the light gauge metal framing contractor to know how to prepare the substrate properly for an air barrier application. You still have to think that, air barriers, even though they've been around, for quite some time, they're still somewhat new in regards to their use and maybe even understanding by the trades. And so the manufacturers of these materials will have very, very specific instructions in regards to what the substrate needs to be in regards to it being acceptable. And when I'm saying acceptable, this is specific to materials that rely on adhesion, not mechanically attached, right? If you are mechanically attached, some of these things aren't going to play into the grained scheme of things. It's more of things that, rely that they actually have to stick to something. So from a design standpoint, right, we always want the specifications to refer to the other related sections. And if you look at an air barrier specification and the related sections, it's extremely long, right? There's so many different things within a wall assembly that can actually impact the air barrier. It's almost hard to even manage sometimes. There's just so many things that touch it, from whoever's doing the exterior cladding to the structure to insulation to through wall flashing to windows. You've got all these trades that are working with the air barrier to make the building airtight. But I'm going to say a top 5 thing that we find in the field is that the substrate is not prepared properly. Okay, so if you're going out onto the job site, pay attention to how well that substrate is prepared. And there's some things that it's going to be really easy to point out going, hey, that's not good. But there's going to be a couple things that are maybe a little bit more hidden, where you have to do a little bit more investigation and digging down to go, hey, is this actually okay to put the air barrier on and it not fail? Because it might not fail right away. It might fail a day later, 2 days later, a week later. So things aren't necessarily, very apparent when the actual installation happens. Okay, so we'll start with concrete masonry units. I'm going to say that this is probably one of the more challenging ones from the aspect of air barrier application. There's 2 reasons for that. One, it's a very porous type substrate. 2, it doesn't have the greatest surface profile, right? So if you actually looked at a concrete masonry unit under a microscope, it looks like a little mountain range. So you have peaks and valleys. And then thirdly, in regards to the substrate itself, it tends to be a little bit more dirty, right? It tends to be able to trap dust and dirt and all those things and kind of some of the pores. So it ends up just being challenging. So overall, they have to be clean, they have to be dry, they have to be properly primed. And I'll give a caveat to that in just the fact that it's primed if you're using a self-adhered membrane, but there are some self-adhered membranes that say they don't require primer. If that is the case, then this concrete masonry unit substrate prep has to be very good, because priming helps cover some sins, right? It kind of helps lock in some of the dirt and debris. It soaks into those pores, and then you're actually adhering to the primer itself. So you've got concrete masonry unit with these pores, you've got this primer that digs into it, kind of locks in, and then you're actually applying the air barrier to it, okay? So I'm going to say out of the biggest issue we find with concrete masonry units, it is moisture that ends up being the biggest culprit. So what can we do? Well, we can't manage Mother Nature, right? There isn't a switch that we can say, hey, turn off the rain for this construction project. So part of that, we're just going to have to deal with it. The second part is, if we know things are going to get wet, what things can we do to make sure that those concrete masonry units are somewhat protected? And if you think of an open course of concrete masonry unit, you get water in there. It acts like a little swimming pool, right? So think of being at the top of a concrete masonry unit wall, you with a garden hose, you're pumping water in there. Well, in essence, we have this little concrete tub of water, and it's going to eventually dry out, but it's going to take some time. So what do we do if the roof is not installed? Well, let's just stop water from getting in there. And there's three different things that I'm showing here. So if you look at the picture of the right, if the roof is not on, which doesn't happen to be the case all the time, sequence of construction, then we should be capping off the top of those concrete masonry units. And a lot of times we can simply just use an air barrier material, whether it's self-adhered or you could do a flexible stainless steel, and we kind of just like stop that water, right? So we're stopping that water from going in. Picture in the middle, sometimes if we have a parapet, and this picture is a massive parapet, but what they've done is they've protected that back side of the parapet with a vapor permeable membrane, so that if water is hitting it, it's kind of keeping it protected. So we've got protection at the top, we've got protection on the back side, and then the picture on the left is actually showing where we have a connection from a poured concrete to concrete CMU. So sometimes, again, you get a rainstorm, the concrete floor just gets tons of water. If it starts to hit kind of that connection between the concrete masonry and the poured concrete, well, we have kind of like this little space that the water is going to get down. As it gets down, it's going to flow down the backside of the parapet and make those concrete masonry units wet. So, if it's not raining, great. If it is raining, we might have to wait, but there are some strategies that we can do to simply keep that moisture out in the first place. Okay, so some things to consider. So other than moisture, right? And moisture is tricky. Like, it's kind of like that bad cousin that comes over to Thanksgiving dinner and you're like, man, I don't want to sit by this guy. So one of the challenges you can have with concrete masonry units is it can look completely dry, but it could be soaking inside. And I'm going to show you a couple pictures a little bit later of how that might manifest itself. But other things that we're going to see, or maybe could be an issue, is, where we have significant gaps, right? So if we have concrete masonry units, we have it maybe connecting to steel or something. If it's, connecting to, say, a different substrate, like, light gauge metal framing, there are some limitations in regards to how those gaps are. Okay, so sometimes we have some tolerances we deal with, sometimes we have some things, but when I'm going around looking and I'm looking at these massive gaps, if you take a picture, look at the picture on the left, you cannot put an air barrier over top of that without some pre-treatment of that condition. Look at that picture of the middle, we see this white stuff. And what that white stuff is, efflorescence. This is a telltale sign that concrete masonry unit has been wet, right? So concrete masonry unit gets wet. As it begins to dry, it starts to pull the minerals and salt to the surface. Okay, so if you start seeing this white stuff on the wall, it's an indication that there's at some point quite a bit of moisture. And number two, the fact that it does have to be cleaned off. Okay, so this is kind of like kind of like salt just on the top, if we try to put a membrane on that, it's not going to stick well, right? So this is a case where I go, hey, we can't install on the substrate without removing some of that efflorescence. And then other things that you could run into is just even things such as fireproofing overspray. So you have, fireproofing going on to some seal structure. Well, now it's gone and spilled all over the concrete masonry units. Well, nothing is going to stick very well to that again. So, obviously everyone's aware that, can't really play around with fireproofing, can't really, touch it and sort of those things. But this is an area that would be a concern because simply nothing would stick well to it. Okay, so gaps, identification of moisture, and overspray. And it could be overspray from other things too. It doesn't have to necessarily be fireproofing, but that's an example that we've kind of seen in the field. Okay, so let's keep rolling here. So if we go to exterior gypsum, it's pretty much the same thing, that it's got to be clean, dry, and properly primed. Again, if the manufacturer requires it. Some of the new vapor permeable membranes have said, hey, we don't need a primer. The kind of older technology of kind of that bitumen base, kind of like black stuff that is on the backside, those tend to always need a primer. So, just looking at the materials itself visually, does it have black stuff on the back or does it not? That typically is a good indication of whether or not it's going to need a primer or whatever. So in this case, some of the same things, right? So we can have significant gaps in the sheathing, right? If we're using self-adhered spray applied or whatever, we have to do some pre-treatment to that. That pre-treatment could be a sealant, it could be some backer rotting caulking, it could be some sheet metal. There's a number of different strategies that can be used, and it's going to depend a little bit on the size of that gap and the air barrier going over top of it. Now, if you have things such as overdriven or oven-driven fasteners, those will tend to be more of an issue for fluid-applied membranes, maybe not as much of an issue for, say, something like a self-adhered, unless there's like a million of these screw holes in there. This tends to be more of an issue with the fluid applied. And then you can see if we do have some damage, obviously we can't just put a piece of self-adhered membrane over top of it. Those only have the ability to span a certain gap. So this would be a time where we'd have to cut out some of that dense glass gold from stud to stud, put in a new piece, and then have ability to actually put an air barrier over top of it. Poured concrete, kind of like concrete masonry units, that it could be dry looking, but actually have quite a bit of moisture inside of it. Okay, so that's where we're going to want to take the advantage of using something that could actually test for moisture content. So in the picture here, it's kind of showing a little bit of a pin probe. Well, that's kind of tough to do on a solid, dense surface such as poured concrete. So there are some moisture meters that you can get that you kind of put, it's almost like orthoscopic, think of a doctor kind of putting, a stethoscope on you and listening to your heartbeat. Well, it's kind of like that you can actually test for moisture in the substrate. But just a word of caution there is it usually can only go about to 3/4 of an inch in. Okay, so you're able to test for moisture content, but just remember, you're really only testing that main surface of it. So if this is 6 inches, you're not really testing the 6 inches, but if you're testing, say, 3/4 of an inch in, hey, that's probably a good indication whether or not it's going to be dry or not. So the substrate, it's going to need priming if that's required. You're still going to have those things such as overspray and things like that would have to be cleaned off. So if you understand kind of the concepts of concrete masonry units, tends to be very applicable to poured concrete too. So some of the things that may be different for poured concrete would be things such as forming oils. So sometimes when we're putting on forms, we might put on an oil. That way the forms don't stick to it very well. So when that happens, you could have contaminants on the surface, right? So there's different strategies of how to clean that off, with a solvent or soap and water or whatever it happens to be to get some of those oils off, because it really impacts the bond. When you look at the two middle pictures, we see some honeycombing and we see some, kind of holes, like we call them bug holes. Well, bug holes aren't necessarily a big deal if you're using a spray foam or a self-adhered membrane. They tend to be more of an issue if you're using a liquid applied membrane. When it comes to kind of the honeycombing, so that's kind of the second picture from the left, you can see again, you have some exposed aggregate. If you're using a self-adhered membrane, maybe you can go over top of it if it's not too bad. If you're using a fluid, you may have to do some grinding, some parging, something to just kind of make it a little bit more smooth. All these materials kind of like this nice smooth substrate. As soon as stuff gets a little bit wonky, it's not a big fan of it. But if you say use something like a spray foam on this, that's going to kind of be able to deal with those inundations and kind of that uneven surface. So depending on the system you're using, some of that honeycombing may be an issue, and sometimes it may not. Now, if we go to wood, it's really going to be the extent of how we handle exterior gypsum, right? Clean, dry, we can check for moisture content. Most recommendations of moisture content is 20% and less. The one good thing about wood is there's actually some guidance. You would be surprised that there really isn't much guidance out there when it comes to concrete masonry units, exterior gypsum board, or poured concrete in regards to what is acceptable moisture content, right? There's some innuendos about what it could be. There might be a reference here, but nothing that says if you're putting on this air barrier, this concrete masonry unit has to be 10% or less, or the gypsum has to be 10% or less. It doesn't exist. We've done a lot of research to find it. It doesn't. So we're trying to figure out what would be some direction that we can get. So we're going to try to do some research on it, because it just simply doesn't exist, right? So it ends up being like, hey, let's install some stuff. Let's hope it works. Maybe we can do some testing, but there isn't a definitive kind of maximum moisture content with a lot of these surfaces. Wood is one of the ones where they've said, listen, we're going to help you out. You can use a pin probe, and we're actually going to give you some direction in regards to it. Hey, 18 to 20% is acceptable. So now let's get into some of the materials. So we've kind of dealt with the general stuff, right? Substrate, ambient temperatures, substrate temperatures, all that sort of stuff. Now let's get into the meat and potatoes of what do we look for when we're looking at these different materials. So we're going to start with self-adhered membrane. If you think of the overall buffet of materials you have to choose, the ones that tend to have the biggest market share have been the fluid applied and the self-adhered. So this is what we see the most. That's followed up by spray foams, and then some of the materials such as insulating board stock and stuff like that. But this is one of the big ones that's used quite a bit. It's got quite a long track record, and you have them available now in permeable and non-permeable. So I kind of think of these materials as like installing wallpaper at your house, right? A lot of the same principles apply in regards to, proper overlap and not a whole lot of crinkles and all that sort of stuff. Another good analogy for substrate prep is if you've ever done, drywall and painting and taping and filling joints in your house, and you don't do a good job when you paint it, it looks like horrible, right? I am nowhere near good at doing like drywall work. And I've tried it at my house, and I've done it. My wife's painted and she almost divorced me. But I think it gives you a good analogy in regards to what the substrate should be when you're putting these things on, right? The more ugly it looks, the more ugly the air barrier is going to be on there. So a lot of the things with these materials are fairly basic, right? It's like a 2-inch overlap, putting on sheets, making sure that we seal around things. We can't span some of those large gaps, right? So if you look at the picture here, we have this large gap. Well, a lot of these materials could only span maybe 1/8 to 1/4, right? So, another thing you'd be looking for going is someone trying to put this material over, say, a gap of 1 inch, a gap of 2 inches, whatever that happens to be. So we have to do something in regards to providing that backing. And, so backer rod and caulking. Is it a piece of sheet metal? Is it a piece of whatever else that we can stick in there? Because these things like to be fully supported, okay? The next thing that is very important is rolling and priming. So it makes a massive difference in regards to using a hand roller to really push this into the substrate. And there is quite a bit of a difference by just kind of patting with your hand, kind of making sure it's stuck well and actually rolling it. So all manufacturers say it has to be rolled with kind of like a countertop roller where you put your full weight into it. Okay, so that actually becomes a very, very important purpose. And one of the reasons why is when you just kind of hand press these things in, you're not getting into those gaps and cracks and crevices. So if you remember what I said about concrete masonry units, if you look at it microscopically, it looks like a mountain range. So if you're just kind of patting it with your hands, it means you're just having it stick to kind of like the top of the mountains and not the bottom of the mountains. So it means that your air barrier really isn't installed well to actually adhere. And it may not show up right away. So you can go, I do a good job, I come back 2 days later and it looks like horrible. It could be a function that it simply wasn't rolled. So if I'm going on site, I'm going, where's your roller, right? I want to make sure that your primer. So if I'm looking to see if they're priming, I want to see that that primer has extended past where that self-adhered membrane is. And then all these things have to be integrated into any holes in the building, right? So we're going to have window rough openings. We might have a roof to wall connection. These things have to be able to transition to what would be considered the other air barrier components. So a window itself is an air barrier, so we have to make that connection. The roof is an air barrier. We have to make that connection. So when we're installing, putting it on where there's no penetrations or tie-ins or anything is pretty straightforward. All the devil is in the details when it comes to where we got a big hole in it, right? And that can be a mechanical penetration. It could be an electrical penetration. It could be, a window, whatever it is, there are proper steps to take to make sure this is installed correctly. So it's not a difficult or complex material to install, but it does take care, right? And again, imagine yourself doing wallpaper at your house and hoping that your wife isn't going to divorce you. You have to do good work, right? It's got to be lined up. It's got to be properly rolled in. We have to have our primer, which could be considered like the glue. So the steps are fairly straightforward to install this type of material. But what goes wrong? Well, let's take a look at these different pictures. Well, so we'll have some wrinkles. We might have some what we call fish mouse. We might have some overexposure. We might have some improper substrate. So we can have all these different types of things happening. So let's start with the picture on the left. So you can see we have this strip of membrane. It's connecting between a concrete masonry unit and exterior gypsum board. So we have two different substrates coming together. Those substrates are going to move differently depending on moisture content and temperature. So we're always going to get like movement here, which can stress things. So when I'm looking at this picture, I'm going, well, the mortar joints haven't been struck flush. Things don't stick well, very good to mortar. So now I've tried to install a membrane on a material that's really not that good to stick to. And we have all these kind of pockets. So, I'm going, this is incorrect. We have to make sure that those joints are struck flush and that we can have that good bond. So if you look at the picture in the middle, well, this is an area where we have, say, some wrinkles and fish mouse. So is this really bad? Well, it's going to depend on, how many wrinkles and is it at an area where water can get in. So it's very important where it's on a vertical seam versus a horizontal seam. So sometimes you might be able to get away with kind of just re-rolling it or whatever. If it's big, it should really be cut out and patched. But if there's only a little bit of wrinkles, it's not the end of the day. We're looking for something a little bit more substantial, where we would have to cut it out and put some type of patch over. One thing to keep in mind with these materials is that they do have a limitation in regards to how long they can be exposed to UV. And UV is great at killing everything. So think of, car, why does paint fade? Well, UV, that's why we have a clear coat. Why do you have to get your house painted every once in a while? Because it gets beat down by UV. So UV kills everything. And so these things actually have to be covered within a certain limit in regards to the UV actually not damaging it. So if I'm going to the site, I'm looking at the technical data sheet that says this has to be covered in 30 days from UV, and I'm going to go, when was this actually installed? And are we starting to go over what that limitation is? The other thing that you might find is you might see like all these wrinkles and you're like, what's going on here? So it's not minor, it's kind of all over the place. So if you look at the picture on the right, that's kind of green, this could be a function of a couple different things. Number one, maybe it hasn't been rolled properly. Okay, so this might have looked great on day one, but by day 3, you start to see the membrane start to debond. So first thing you might go to mind, this wasn't rolled. So the installer says, you know what, but it was absolutely rolled. I don't know why this is happening. Number 2, there was substrate that had too much moisture in it. Okay, so again, that moisture starts to dry out of that substrate. It starts to debond the material. Okay, so the installer's like, well, no, I rolled it and hey, I checked it for moisture, was good. Option number 3, if they don't let the primer set up enough time and they put it over a fresh primer that hasn't cured, again, it will not stick properly. Okay, so if you see a whole bunch of wrinkles all over the place, it's going to be in those 3 categories of not rolled, substrate moisture content too high, or the fact they put the material over primer that wasn't cured. Okay, so kind of the 3 different whys that it's happening. A lot of times, if it's really bad, you may have to take it off and reinstall it. Sometimes you can get away with just rolling it a little bit more to try to get away those, wrinkles. It's really a case-by-case basis in regards to how bad and how much it is wrinkling, right? Okay, moving along. We're going to go into fluid applied membranes. So some of the things that are important, all these fluid applied materials are made up of a number of components. So if you look at self-adhered, you're kind of using self-adhered and some sealants, and that kind of does like 95% of the job. When you go to something like a fluid applied or roller applied or whatever it happens to be, it's usually the liquid in combination with, say, a self-adhered membrane or meshes and tapes and other sealants. So it ends up having a lot more components to it. So none of these materials have the ability to jump gaps. So that's where we're going to look for things such as all the joints and seams pre-treated prior to the application of the spray or the liquid applied happening. So a lot of the legwork with these materials is all the prep work. The spraying part's pretty straightforward. It's all the prep work. And again, think of painting your house inside. You've done the best you can of taping the seams and dealing with the butt joints and all about, all that sort of stuff. And you go to paint it, it looks crappy. So again, think of this, that it needs to look pretty good, and then you spray it, and then that spray application should look pretty consistent. So there will be a little bit more temperature restrictions with these materials. So some, depending on the technology, maybe it can't be as cold as maybe what a self-adhered could be. Some of them have limitations in regards to how hot it can be too. So we're looking at both cold and hot. We don't want to spray these things too thick at once because they can start to droop, and I'm going to kind of show. And probably the biggest thing that we see in the field is thickness not meeting either the performance requirement in the specification or what the manufacturer recommends. Okay, so self-adhered, it comes out of the factory, we put it on the wall, we're not guessing what the thickness is. With these fluid applieds, each manufacturer is going to have a different requirement that they need for thickness. And so if it's supposed to be 40 mils dry, and we go and check and it's 20 mils dry, well, we only have half of the material there. So most of the time we're finding that the installer maybe hasn't put on as much as they should have. What happens if we put a little bit too much on? Tends to not be the end of the world. The only impact it might have is if it's a vapor permeable system and we put on so much that we actually start to change how vapor permeable that is. In reality, it probably doesn't make much of a difference, right? If you actually think about a vapor retarder and like 1 perms and 5 perms and 10 perms, there's not a whole lot of difference between them. So it's probably not a big of an issue. It tends to be more of the issue where we simply haven't put on as much as we should have. So we're taking a look here. We're going, is everything nice? Are all the screw heads detailed? Are all the joints detailed? We have to think about the material that we're using. So if you take a picture, look at the picture on the left, here's a case where we had a sudden rain event. So if we're using a material that's, say, water-based, it goes on, hey, great job. It happens to rain before it's cured, we can actually start to wash these things off. So if you're walking around the job site and you see this isn't probably that the fact that they just missed a whole bunch of areas. This is the fact where the material wasn't cured and it literally started to droop down the wall. So this is where the installer has to be concerned with not only the ambient and temperatures at time of application, but going, hey, what's going to happen tonight? What might happen tomorrow that can impact my installation? And if you happen to be in an urban area, then maybe doing a fluid applied or spray applied doesn't make sense. Maybe you have to go to a roller application. People tend to not want a whole bunch of flecks of fluid applied membranes on their cars. So you have to be very careful. So let's take a look at some of the things that we might find. Well, extended exposure to UV. So if you start to see a bit of a chalkiness to it, if it starts to kind of change colors, that could be an indication of it exposed to UV. If you look at exposed to high temperatures, well, if these things get exposed to extremely, extremely high temperatures, again, it might not crystallize, but it almost comes up with like a little bit of an alligator skin. Okay, so if you see an alligator skin, that might be the fact that it's just been exposed to a high temperature. So darker materials will tend to get impacted more than lighter materials. You know, darker materials absorb more UV, get hotter. And then the other thing that you might see is unadhered membrane. So the self-adhered membrane now is the substrate. Okay, so now it's almost like the installer has to prepare the concrete masonry units, but they also have to prepare and make sure that the self-adhered membranes are clean. Otherwise, we're not going to get adhesion. Okay, so we're always looking for adhesion to the substrate, but also adhesion to things that it has to stick to, such as transition membranes. Well, let's take another look. So here is what might happen if you have moisture in the substrate. So we've put our air barrier on, we've trapped some moisture in there, we've kind of made a pool. Like we've put this membrane on, it's like a pool liner. So now that moisture is in the substrate, we got the sun beating down on this black membrane, and now that substrate starts to kind of dry out. And so you start to pull all that moisture to the surface of the membrane, and it creates these little bubbles or blisters. Okay, so if you go around and see bubbles or blisters, 9 times out of 10, that's an indication that we have substrate moisture content that was too high at time of application. What's the fix? Well, it could be fairly easy in the fact that we're just poking these things through, applying a little bit more material, and then definitely monitoring the project going forward to make sure that we're not running into this condition, because this may not happen right away. So if we covered this with, say, exterior insulation right off the bat, we might not see this, right? It might be covered up. This may need some time to manifest itself. Other things that we might find, well, if there's things in the wall system already and we're spraying, well, we have to make sure that we're spraying down, sideways, and up. So we have a term called shadow effect. So if you have masonry ties, if you have other things coming out, a lot of times we'll say, hey, the installer was spraying up, but maybe he forgot to get underneath that masonry tie. So we're looking for kind of voids around any kind of penetration coming through. The other things that you might see are these small holes, and we'll put them into the category of fish eyes or pinholes. So think of a fish eye where it's just like a little bubble, a lot bigger than what we looked on that other slide. And then when it pops, it becomes a pinhole. So again, this tends to mean that we've had some issues with moisture within the substrate. As it's dried and started to cure, it's tried to work its way through its material, created a bug eye, and then when the bug eye bursts, then we've got this little hole. So there's going to have to be a little bit of work in regards to applying a little bit more. Another thing that we can kind of see is what we call cratering. And so if you look at the picture at the left and you're like, Ryan, it looks like someone shot a BB gun at it. And I'm like, that's kind of what's happening. And so what happens in this case is the fact that you can get the material curing in the bucket. It's usually in a bucket or barrel. And if it starts to cure into a solid material and then you're spraying it, that pump's actually going to pick up some of that solid material. So I'm going and I'm spraying this wall with a liquid, and within that liquid, I have all these solid chunks of fluid applied membrane that's cured because maybe I haven't taken care of properly protecting the barrel or the bucket from just being cured by the ambient temperatures around it. Okay, so if you see BB gun, that's probably an issue with the fact with the applicator spraying it. What's the fix? Well, we typically just have to put a little bit more on. And you can kind of see an example of that of the picture at the right. So this person hasn't brought an octopus out of the fluid applied membrane. This is really kind of that skim coat on the top of the fluid applied membrane that cures because of contact with air. It gets heavy, goes down to the bottom, and then we suck it into the pump. Okay, so typically looks like it got shot by a BB gun. We know that there's probably an issue with the equipment that has picked up some solid material. Now, material slumping will sometimes take place where the installer has installed it just too thick. So some of these membranes say, hey, it's going to be, let's just say 80 mils wet. And they will say, well, do 40, let it cure, and then do another 40. Well, if you go and try to just blast 80 met wills on and not follow the manufacturer's instructions, you can get that slumping. Okay, so you will literally see this start to fall down the wall. And that's because of just simply gravity pulling off. The material takes some time to cure. And because it is heavy, you've sprayed it on too thick, it starts to pull down the wall. So if you see something like this, this is typically an issue where they simply just put on too much at once, and it should be done in 2 passes, not just 1. Okay, so how do we check for thickness? Well, there's kind of like 3 different ways. The easy way is a wet mill gauge, right? So while the installer's applying, you have this little wet mill gauge. It's going to say, hey, it's 20, 30, 40. Super easy to do, can be done throughout the construction project. Now, if it's cured already, and we want to get a dry thickness sample, then typically we'll use a digital thickness gauge or another one that's kind of a digital it's called a fine scheme comparator. Think of it as almost like a little telescope and you're kind of looking at it and then trying to line it up with what the thickness is. I tend to like the digital gauge. It's easy. It gives you a number. Some of the challenges might be if you are doing thickness testing is sometimes the fluids or whatever will be stuck so well that you'll end up like ripping off the face of the, say, exterior gypsum board. So that can be a challenge sometimes because you're actually now testing the thickness of 2 things, not just 1. So you try to scrape off the substrate as best you can. Option 2 is you can actually find out the thickness of that facer, do the thickness testing of everything, and then just minus that facer. So this is fairly easy easy to do during construction and also after. All right, so we're going to get into spray foams. Now, these ones are definitely more challenging. So they're very complex in regards to we're using chemicals and equipment, and there's very specialized health and safety issues. So this isn't, hey, I wake up this morning going, I'm going to get into this business. It is very dependent on the qualifications of installers, because in essence, they manufacture, right? So they're buying two chemicals, they're actually making the reaction. So they are the site manufacturer, and things can definitely go quite wrong or quite sideways quickly. So one of the things with spray foam is it needs to be used in conjunction with transition materials. Okay, so this isn't a one-all system where we actually just go and blast foam everywhere. We have to use it to tie into windows, roof wall connections, whatever it happens to be, and that's usually using self-adhered membrane or fluid-plied flashing. The one thing to look at is those self-adhered membranes have to stick well. And the reason why it's important with the spray foam is these things are sprayed on fairly hot. So it's two chemicals coming together under pressure and temperature. When you spray it on, it's warm to the touch. It gets very, very warm to the touch. Well, once it cools, it starts to kind of contract, okay? And as it contracts, it actually has a pretty big force that it wants to start to rip things off. So when you are spraying and it's going over a membrane, the installer should only be doing, they shouldn't be blasting it on thick. They should maybe do thinner passes with not as much heat buildup. So if you're walking around, just take your fist and pound it on the wall, pound it on the spray foam, and feel for any voids. Okay, so a void would be an area where it simply isn't stuck well, because it might look great. So this is one you have to maybe do a little bit more testing. So we want to look for a smooth application. We want to make sure that there's enough foam going through things like masonry ties, so we can have that shadow effect, just like we did with fluids. And thickness, again, is probably one of the biggest things, right? So these are sprayed at 1, 2, 3, 4, whatever thickness. So we have to go out there and do thickness testing on the final product, right? So we're not doing wet melt testing. We're doing, in essence, testing after the foam has cured. Typically going thicker isn't an issue. You've given away some free material. But if it's too thick, that might impact in case there's a certain, say, gap or airspace that's needed behind the cladding for some specific reason. If that's the case, there might have to be a little bit of shaving down of the material. So things that we see in the field, well, adhesion, right? So it's just simply not sticking to the substrate. It can be off ratio. So what I mean by off ratio is you have a cup of A component, you have a cup of B component. They're supposed to be mixed at the exact same amount. And once those things go off, which usually means there's, say, a clog in one of the lines, then you get too much of one chemical. Okay, so if it's resin rich, which means it's too much on the resin side of things, it tends to be a softer foam or a darker in color. If it's an iso-rich foam, it tends to be lighter in color and almost like what's that candy bar? Coffee Crisp. It reminds me of Coffee Crisp. So very kind of like crinkly, chunky. It's kind of hard. So look for soft or hard, and color variation will give you an indication if it's off ratio. The other thing we'll see is thermal cracking. Now, thermal cracking happens when it's sprayed too thick or too quickly. So because these spray foams are good insulators, they're sprayed on hot, and then because they insulate well, it takes time for that heat to dissipate. So most manufacturers would have a restriction that says only spray at 2 inches or 3 inches or whatever. I think some of the newer ones you can go a little bit more. But if you go too much and it gets too hot, you can actually start to crack it, right? So it starts to kind of shrink, it starts to pull. So if you see a big crack, that tends to mean it's been sprayed too thick or too quickly, okay? And sometimes the only fix is taking stuff out and actually spraying it again because the foam just hasn't set up. The other thing you can do is just simply take a chunk out the wall, right? So we're looking for these nice, fine, round, coarse cells, right? And once it starts to have big cells, open cells, kind of furry things, all that different type of stuff, that's an indication where it simply isn't setting up correctly, okay? So you should have a sample piece of what it should look like, and then compare it to what I'm seeing in the pictures here that would indicate, hey, I've got a bunch of holes, it's not coming out as good, I've got some, it looks like it's growing hair, something's wrong here, okay? So poor cell structure is a good indication of how it's been supplied. Now, if we look at it visually, this gives us an idea of the skill of the installer, okay? So if it looks like a dog's breakfast, that is a good indication that whoever was spraying it either wasn't trained properly, didn't have their equipment settings, whatever that happens to be. So just visually looking at it, you can kind of get a story if it's good or not. Now, one physical test you can do with spray foam is the fact that you can do something called density testing. And that density testing is going to give you a number that you can compare to what the manufacturer says it should be. And if it's within that range, you know it's been processed and mixed right. So we don't have that with fluid applieds. Spray foam, we actually have it. It's a very simple test where all we need is the weight and the volume. And the weight, we would just simply use a little scale. And for the volume, if you remember going to high school and you had a beaker, we find out the volume of the foam by putting some water in there. We put in a sample. That's going to tell us how much there's in there when we take the water without, and then the water with, that gives us volume. And then with some calculations, we're going to find out what it is. So I know I'm kind of at my time here, so I'm just going to kind of go through the next ones, which are fairly quickly here. So insulating board stock, this is where we're simply using the insulation board and treating. So again, insulation, and we're either using a self-adhered membrane or we're using a fluid applied flashing. So the principles are the same in regards to this and say non-insulating board stock, that we need materials to seal it up. The other thing that is important with these systems is the manufacturer will have very specific fastening patterns and specific fasteners that should be used when it's an air barrier application. So they might say you have to use this type of fastener with this plastic cap thing, and it has to be this if you're using it as an air barrier application. If you're not, then maybe there's opportunities to use different things. But the real things to look at with these systems, it's all about the detailing of the joints and seams. And what we find is that, the tapes are just simply not sticking well, right? The installer hasn't cleaned off that insulation board. They've tried to put the tape on and it simply doesn't stick. The other thing that we tend to see in the field is this all goes on, it looks nice, and then someone comes behind and puts a big hole in it with mechanical or electrical, and that hasn't been detailed properly. So these ones, if you're showing up on the job site, fasteners and making sure that the joints and everything is sealed and that adhesion of that tape is proper on the board. Now, non-insulating board stock, this is kind of where you're just using exterior gypsum and the same process as insulating board stock, where we're really just taping the joints. So some of them will just use a board and sealant. Some new systems actually have the air barrier applied at a factory, and it comes out, we put it on the wall, and we're just simply screwing it in, and again, detailing the tapes and seams and things like that. So here's a couple pictures, right? There is one that's an actual full self-adhered membrane on the wall. So again, the focus is on screws and joints and seams within the thing. So that the air barrier is already on, we're not worrying about that. We're just detailing those themes. So if you think of insulating board stock and non-insulating board stock, really the same types of things to look at and the same process to go through. Now for commercial building wrap, these are fairly straightforward, right? So they're going to have very specific fastening and fastening patterns. And if it's used as a water resistive barrier versus an air barrier, there can be quite a bit of a difference in regards to the tapes used and the types of fasteners used. Okay, so making sure that there is a big difference between this material being installed as an air barrier system versus a water resistive barrier. A lot of times it is the water resistive barrier, and there are differences between the two different functions it might perform. So again, it's going to be mechanically attached, so we're maybe not as concerned about the substrate. It's more of like things sticking out of it. Here's an example of someone taking a staple gun and just like putting a million staples through it. Well, here's where I'm going. Well, the manufacturer says that's not cool. You need to use a plastic cap staple or plastic cap nail, whatever it happens to be. And then we're looking for things that could rip it, right? So do we have screws or nails or anything that's protruding that we try to go over top of it? And there's a chance that could actually tear it. And then the third thing is these things do have to integrate into the window assemblies. So a lot of times the manufacturers will have like flexible flashings. They might have a preformed sill pan. They'll have some different things that we can make that connection between the building wrap and then say the window. And it could depend a little bit, the type of window, right? Is it a flange window that we're maybe connecting to the top of the flange? Is it the fact that we're just going to wrap into the rough opening and we connect the window frame to the air barrier with a sealant or something like that? So again, the integration of the systems is where most things fall apart. Okay, so this is the end of the presentation. And so what you're going to find in the slideshow is I have a whole chunk here on adhesion testing and going through it. So we don't have time to go through it, but just something for you to have that just talks about how to conduct it. Okay, so you would conduct this test on a fluid applied, on a spray foam, or a self-adhered membrane, right? And so we have a step-by-step process and test standard that you can use that walks you through both how to do it and how to interpret and document the results. So a good resource for you to have. I'm happy to do another presentation on it in the future, but something that I just wanted to mention in case you get the slides and going, what the heck, Ryan never talked about this stuff. So on purpose, it's there. I knew I'd be overtime no matter what. So I'm going to pass it back to you, and here to entertain any questions or comments that people have.
No worries. And if you need to hop off, we are a little over, so no worries on hopping off. Do have a few questions. Amy asks, what happens if water pools on the concrete abutting the concrete building wall?
Yeah, so if you do have moisture there, right, it does have that ability. So if you are using concrete masonry units and a poured concrete, those two things will connect. They're typically never sealed. So what we've seen people do is actually put like a little strip of a membrane where those two things intersect. And that helps from that water kind of ponding and getting into the exterior wall surface. So say a whole floor kind of floods out, and hopefully it's not 2 feet, that at least that would keep the water contained on the floor and not provided its ability to get onto the backside of that wall assembly.
Yeah. And then, well, I just like to advise everybody to stay away from wallpaper completely, by the way.
Unless you want to be divorced.
A little public service announcement there. It's just the worst. I don't get it. Yeah, I just can't. I mean, CMU or just concrete in general, we have a couple of hours of, I ran across this guy that actually did his PhD on concrete moisture for specifications of concrete moisture allowable for flooring installations. But I would imagine a lot of the same, thoughts and ASTM, but well, I guess it would be a different standard for flooring versus, I'm just thinking important. I mean, you might have to sit there for much longer than your building owner wants to sit in between phases of construction before you get concrete or CMU properly dry. I'm sure that's a challenge. And another challenge, looking at that roller, I've never met at least on a residential job, I've never met a framer with a roller to actually apply pressure to those self-adhering membranes at once.
Yeah, for sure.
Yeah. Would you say I guess between dissimilar materials and the prep, I mean, I guess you pretty well outlined many of the challenges throughout the process of air barriers. Have you gotten into the weeds in the 2021 energy code? I foresee I would think we're going to get some more. It will lend itself to paying more attention to the details on air barriers when we're testing more buildings, and the air barrier inspection and commissioning that's required if you don't test. And have you gotten into the weeds of the 2021 requirements yet?
Yeah, there's lots of stuff going on in the code. So like for sure, like whole building air tightness, where you test the whole enchilada, right? Roof, wall, absolutely everything. So I think that's going to provide more scrutiny. There are some jurisdictions like the state of Washington where that test is mandatory and you pass it. And if it doesn't pass, you fix it. You have to test again before you'll actually get an occupancy permit.
Yeah.
So in the ICC, like they have whole building testing as a code compliance path. Mm-hmm. Not a lot of people take it because the other paths are frankly way easier. But I think as we go to like net zero buildings and high performance buildings and whole building, there's just going to be more and more scrutiny on air barriers, but everything, right? Windows, insulation, it's like whole wall sandwich. Yeah, lots going on.
And Washington's kind of leading the way. The way I interpret that section of the 2021, you have to blower door test, depending on climate zone and building type and size. There are some instances where you have to blower door test. It'll say shall, and then go back, and then later it says, well, if you don't, then you can. And I was like, well, if you shall do something, there shouldn't be a follow-up with that if you don't. I'm needing to submit to ICC for an interpretation on that one.
Yeah, no kidding, eh? Yeah, so it is, definitely, challenging with that, the shall or whatever, So again, I guess it depends too a little bit, kind of you got the ICC as a model code, and then what the state actually adopts, and does it adopt with amendments, and kind of each state's a little bit different. So it'll be interesting to see how each state adopts these things specifically, if they make it a little bit more stringent, a little bit less, but the code has been, it's always an interesting process, and it's not necessarily technical, sometimes political more than anything else.
No, it's really frustrating. And Joseph was asking about adding air barrier inspections for like municipal inspection departments, or I would think typically you're best off on commercial jobs. Well, residential, you typically have your third-party energy rater that's going to come look at the air barrier and insulation installation for you, because they're going to do the blower door test, and so they're incentivized to make sure and find all the holes. Would you think that on commercial jobs, especially where would you think the third-party engineer is better to do the air barrier inspections, or municipal? Do you have any thoughts on those lines?
Yeah, I don't know if it's if there's a very specific answer, right? So right now we see really on commercial buildings mostly being done by consultants that are engaged third party by the owner, general contractor, or whatever. So I don't know if there's necessarily an opinion of who's best suited to it, as long as people know what they're looking for and can do it well. Does it become a special inspection type thing in the code in the future? It could go either way, and maybe it's different from jurisdiction and jurisdiction. And then I guess it's, you got a lot on your plate. So it's like you're inspecting everything. Does this get added to your scope, and can you do you have the resources to add one more thing to the list? So yeah, something for I guess you to figure out.
Yeah, makes sense. Okay, well, that's all the questions, Ryan. I can't thank you enough. Fantastic presentation. I just really kind of hoping to get air barriers more on folks' mind as they, the code requirements become a little more stringent, and we really kind of start needing to be thinking about these things a little bit more. So I appreciate it. It was a fantastic presentation, and thanks everybody for joining us, and we'll see you. We have another one tomorrow. I can't remember what it's over, but we'll be back in the morning. Thanks everybody.
All right. Yeah. Thanks for having me. Have a great day.
Awesome. You too.
Okay.
Bye, Ryan.
Bye.